How does polling differ from interrupt handling in embedded systems? Imagine you're trying to catch a bus. You could stand at the stop and keep checking if it has arrived, or you could wait for a bell to ring when it gets there. Both ways work, but they are very different in how they manage your time and effort. In embedded systems, this is similar to how devices communicate with the processor. Let's explore how polling and interrupt handling differ in these systems. Polling is like constantly asking a device if it needs attention. The processor keeps checking the status of a device over and over again at regular intervals. This means the processor spends time actively checking, even if nothing has changed. It is simple to set up because you just write a loop that checks the device status repeatedly. But this can waste a lot of processing power because the CPU is busy checking devices that might not need anything. It also makes the system less responsive because the CPU can only check one thing at a time and might miss quick events. Interrupt handling is more like the bus ringing a bell when it arrives. Instead of checking all the time, the device sends a signal called an interrupt when it needs attention. When the CPU receives this signal, it stops what it is doing and runs a special piece of code called an interrupt service routine. This routine quickly handles the event, and then the CPU goes back to what it was doing. This method allows the CPU to do other tasks or go into low power mode until needed. It is more efficient because the CPU only reacts when something important happens. From an electrical engineering point of view, choosing between polling and interrupts depends on what the system needs. If the system has simple, predictable events, polling might be enough. It is easy to implement and works well for tasks that happen regularly. But if the system needs to respond quickly to rare or unpredictable events, interrupts are better. They save processing power and reduce delays, making the system more responsive. In real-world embedded applications, you often see a mix of both. For example, a button press might trigger an interrupt because it needs immediate attention. Meanwhile, a routine task like checking temperature sensors might be done with polling because it is less critical. This hybrid approach helps balance system complexity and performance. So, polling keeps checking devices constantly, which can waste CPU time, while interrupt handling waits for devices to signal when they need help. This makes interrupts more efficient and better suited for real-time tasks. Understanding these differences helps in designing smarter, more responsive embedded systems.